Okay, so last time what we did do was we dealt with expected value, if you remember. Here we go. Okay, so I did email the notes, so you should have them. And with expected value, so basically remember with expected value, basically it's the average gain or loss of a procedure. If you were to repeat that procedure many times, basically here what we're going to focus on are procedures involving money. You know, like games, like kind of like the examples I tried to do last time, where if some outcome occurs, you win money. If another outcome occurs, you lose money. That kind of procedure. And the idea with expected value, remember, is it's a way to determine if you should play the game over in the long run or not. In other words, with expected value, expected value tells you whether you're going to lose money or gain money in the long run if you were to play the game many, many, many times. Okay? You know, sometimes you might win money, sometimes you might lose a lot of money, but in the long run, expected value is how much you should expect to win or lose if you keep on playing the game over and over again. The examples last time did present the procedure for calculating expected value. The procedure is not that bad, actually. Essentially, you just get each outcome, and what you do is you multiply how much you win or lose from that outcome times the probability of that outcome occurring. So it's how much you should expect to win or lose from that outcome, and then you multiply by the probability of that outcome. You do this for each outcomes and you add up the results. So that's what you're going to end up doing. All right. Okay, so that's what expected value is. I want to do some examples. So for instance, let's suppose we decide to play. This actually was an example we did last time. I think I finished off with it, but I feel better going through it again. Although I don't think I finished it fully. But anyway, we'll do this. So suppose we're playing a game now, okay? Where we roll a standard six-sided die. You know, we're rolling that once. Let's say if you roll a 6, you end up getting $3, okay? If you roll a 5, you don't get anything. And if, though, you happen to roll something less than a 5, like, you know, a 1, a 2, a 3, or a 4, you lose $1. So let's get the expected value of this game. And again, the expected value, it's how much we should expect to win if we were to keep playing this game over and over again. So what I did make was a table. Why is the formatting so weird? Let me fix this. All right, hold on. Let me just, oh my gosh. Okay, let me just quickly do this. There, that's better now. That should do it. Good. Okay, there we go. Not sure why I did that. All right, anyway, so with expected value, again, what I did was I made a table to try and sort the outcomes along with their probabilities. So remember, if we roll a 6, okay, if we happen to roll a 6, what we do is we earn $3. Okay, but what's the probability that we roll a 6, though? The probability is 1 over 6. You know, that's the probability that we roll a 6. Okay, so in this case, the product, which is 3 times the 6, you know, that's 50 cents, right? Which is 3 over 6, which is the same as 50, but we like to write it as money, so it's 50 cents. Okay, if we roll a 5, then remember, by definition, we don't get anything, right? We get nothing, so we get it. So we get nothing. The probability of that happening, remember, is 1 over 6 as well. Okay, that's the probability of that happening is also 1 over 6. So in this case, the product would be 0. 0 times anything is 0. And if we roll anything else, we lose $1, okay? The probability there of each one is 1 over 6, okay? right? So for each of these products, actually, it's going to be -1 times 1 over 6, which is -1 over 6, which actually works out to be about -0.167. Okay. The product is in terms of dollars, so we get -0.167. Okay. Same thing with rolling a 2, a 3, and a 4, and so on. Okay. All right. And so finally, to get the expected value, what do? We add up the products, right? So we have 50 cents plus 0, and then we're adding up. These are negatives, so that's the same thing as subtracting. And if we did this, we end up getting about -0.17 cents. Okay, so that's what we end up getting here. So really, since this is negative, in the long run, this is not the game we really should be playing. I mean, sometimes you're going to win $3. Sometimes you're not going to win. But if we keep playing this game over and over again, we should expect to lose money. I mean, granted, 17 cents is not terrible, but still, it's not a positive number. So that's what's happening here. So again, what did we do? For each outcome, we got the probability. We also, from the problem, got how much you gain or lose from each dollar. You gain or lose from each outcome, or you earn nothing. We multiplied and added up the products. So that's what we did here. Okay. All right. So here's another example I wanted to do as well. Actually, sorry, but first, are there any questions about this? All right. So here for this expected value, okay, so here's another example now. This one I actually got from the book. A company now estimates that 0.7% of their products, right, will fail after the original warranty period, which is after that ends, but within 2 years of the purchase, with a replacement cost of $350. So in other words, if a product fails, it breaks down, whatever that product is, within the warranty period, within 2 years, it will cost the company $350. If they were to offer, though, a 2-year extended warranty of $48, okay? So if a customer buys a warranty, remember, they can send it back and the company would be responsible for fixing it. What is the company's expected value of each warranty, though? Okay, so here we have a company that's selling products, right? If the product breaks down within the warranty period, it will cost the company $350, right? But each warranty, though, each 2-year extended warranty is $48. Okay, so for the company, what is the expected value? So we're looking at this from the company's point of view. Okay, we're looking at this from the company's point of view, right? So the two outcomes would be if the product fails within 2 years, right? That's how long the warranty is, or if the product does not fail within 2 years. Okay. Okay, well, if it fails within 2 years, how much is the company going to make? Well, they're going to get $48 from the warranty, right? But they have to fix the product, they have to replace it, and for them, it's going to cost $350. So, of course, if you subtract, right, you could think of the $350 as negative, right? Because it's costing the company, the company's profits. So the company will make negative $302. In other words, it's going to lose $302. They get $48 from the warranty, but they lose $350, for replacing the product. So if the product does fail, they're going to lose $302. Remember, this is for each warranty sold. Okay, but how likely is this to happen? Well, if you remember also, about 0.7% of the products, 0.7% of them will fail after the warranty period, right? But within 2 years. So that gives us our probability. I mean, you want to convert it to a decimal, though, which is 0.007. So this is how likely the product will fail. 0.7%, which is 0.007. Okay. Okay, so what's the product? Well, we have the amount that's lost in this case times the probability, which is this, as you can see. Okay. But now that's if the product fails. What if the product does not fail? Well, they don't have to worry about replacement costs, right? So what's going to happen is they're going to make $48 from that warranty. Okay, well, how likely is that going to happen though? Well, remember, if you have an event and you know its probability, the complement of it, meaning that event does not happen, it's 1 minus the probability. You know, we did see that last time, right? We have event E, and if we know its probability, then 1 minus the probability of E is the probability of the complement of E, which is the event that E does not happen. Well, if a product does not break down, right? Excuse me, if a product does break down, then its complement would be it does not break down. So that'd be 1 minus, which is 0.993. So in this case, the product would be $48 times 0.993, which turns out to be this. Okay, so again, we have our products. If we were to add them, this is what we get. So in other words, this is a positive expected value. So the company would expect to gain from this, from having these warranties. From each warranty, the company should expect to gain about $45.55. So this is a good idea for the company. So I guess in this case, the procedure would be, you know, selling each warranty for $48. So sometimes they're going to have to fix the product. So sometimes they will lose $350, but not always. But in the long run, each warranty will bring them about $45.55 profit, approximately. Okay, so we have that. Okay, before I start chapter 9, which is the next one, next what do you call it? Next chapter. Can't think of the word. I just want to ask this stuff. Okay, let me get the poll going. Okay, does this make sense? You know, you can be honest. I really want to make sure everyone understands this. Those examples with expected value, I mean. Was a little worried about the second example. I do practice my election notes the night before. I run through them to see that makes sense. I was worried it didn't. Wow. Nice. All right. Okay, then. In that case, let me now start chapter 9. Okay? Okay, so I'm going to start chapter 9. Let me just stop the